Let's locate these angles on the unit circle. This is pi over 4, and we have pi over 8 and 3 pi over 8. And then our angles are in between. Here's pi over 16 and so on. They're all located in the first quadrant, and they're evenly distributed between 0 and 90 degrees. We notice that the outside and inside pairs of angles have a symmetry. So if the x-coordinate of this angle is a and the y-coordinate is b, when I draw this line over here, this distance is b and this distance is a. So we have, for example, the tangent of pi over 16, which is b over a, is the reciprocal of the tangent of 7 pi over 16, which is a over b. To save a little time, I'm going to do some variable substitutions. We'll let x, y, p, and q be the tangents of pi over 16, 3 pi, 5 pi, and 7 pi over 16. So p is going to be 1 over y, and q is going to be 1 over x. Let's rewrite their given equation in terms of these variables. Here's this expression written in terms of the variables, and it's easier to see that we can factor out x squared from the first two terms. And when we factor out q squared from the last two terms, we also have y squared plus p squared, which we can factor out again, leaving us with x squared plus q squared as our second factor. Now we can substitute for p and q 1 over y and 1 over x. You should recognize factors of this form, a squared plus 1 over a squared, because it has some unique properties. You can generate this expression by squaring a plus 1 over a, and then the middle term ends up being 2, so when you subtract 2, these two expressions are equal. Let's keep going with this. Let's say that a is equal to the tangent of some angle b. So this will be tan b plus 1 over tangent of b squared minus 2. And I'll substitute for the sine and cosine. We'll find a common denominator here and add the two fractions. The numerator here, sine squared plus cosine squared, is always equal to 1 for any angle. And this looks like half of the double angle, so we'll replace this with 1/2 sine of 2b. We'll simplify this fraction and square it at the same time. 2 squared in the numerator is 4, and the denominator is sine squared 2b, and we still have our minus 2. We'll go ahead and plug this in for our y and x. For y, we're using our angle is 3 pi over 16, and we're going to double that for this sine expression. So let's use our half angle formula to find the sine of pi over 8 and 3 pi over 8, so we can do the substitution. By squaring it, we can leave out the square root sign. The sine squared of pi over 8 is in the numerator 1 minus cosine pi over 4 over 2, and we'll simplify, and we'll do the same thing for 3 pi over 8. Okay, we'll substitute for our first factor. We have a fraction with 4 in the numerator, sine squared of 2b, where our angle here for y is 3 pi over 16. We'll use this one, subtract 2, and now for our second factor. Let's clean up these fractions, and we'll add each of these pairs of terms and clean up the numerator. When multiplying these two fractions, multiplying the numerators and the denominators, they both are difference of squares, so we can just square the first term and subtract the square of the second term. So in the numerator, that's 12 squared, or 144, minus the square of the second term, which is 8. And difference of squares in the bottom as well. This is 4 minus 2. The denominator is 2, so we'll divide each of these terms by 2, and our answer is 68, which is option B. If you'd like me to solve any other math contest problems, please leave them in the comments.